Okay, so now I want to go the other direction. I'm going to start with the function g of x equal 5 over 2 minus 3x. And I want to write this as a power series and determine on what radius of convergence and what interval of convergence that those two things are equal. So the trick here is to rewrite this function g of x so that it is of this form 1 over 1 minus something. So I want to try to get g to look like this 1 over 1 minus something, and then that'll equal whatever that thing is to the nth power, and it'll converge on the absolute value of that thing less than 1. These are all going to work like this. So what we're going to do here is we're going to factor out this 5 halves out of this guy. So out of the top and out of the bottom. So that g of x can be rewritten as 5 halves times the fraction 1 on top, yay, and then factor out a 2 here, we get 1 minus, and then divide this 3 halves by 2, 1 minus 3 halves x. And now we can see this 3 halves x matches my a. This is the form that I want. So this thing is equal to, I can just leave the 5 halves out in front if I want, and then I get the sum from n equals 0 to infinity of the 3 halves x to the power n. I mean, this essentially is done. Or you can kind of keep going. If you wanted to simplify this, you could bring that 5. I don't know if it's simplifying it or making it more complicated, but you can bring the 5 halves inside. So just so that you can see how some of these things become this format. Normally this 5 halves might come inside here. The 5 we'd leave alone, but the half we would put with this half downstairs, and we'd get 1 half to the n plus 1 times 3 to the n times x to the n. So this problem, if we were going the other direction, might have started like this. We'd have to rewrite it like this by pulling a half out, 5 halves pull out, and then this whole thing is 3 halves to the n, go back up. But if we're just trying to find the power series, I think this is sufficient. We could stop there and be done. I just want us to see how these two things are related from there to there. Okay, and then all I need to do is find the interval of convergence back over here. That's the 3 halves x in absolute value, so that's not going to change its value because it's positive already, and we need that to be less than 1. When I say it's positive, the 3 halves, the coefficient is positive. The x can be both positive and negative, as we'll see here, because 3 halves x has to then be between -1 and 1 to get rid of the absolute values. We're going to multiply all of this by 2/3, all three pieces. We get -2/3 is less than x is less than 2/3. My interval of convergence is this. I can write it in interval notation. -2/3 to 2/3. It's centered at 0, so its radius just equals 2/3 again. That total distance is 4/3. Cut it in half, you get 2/3. And then that problem is done. And so the work really happens in understanding that we're trying to use this thing up here in both directions, going from a function to the power series, going from the power series back to the function. And the work really happens in trying to get one of those two formats at the top before we start. 1 over 1 minus a, or sum from n equals 0 to infinity of something a to the n. Okay, and then I'll go down and do another problem. And I'll post these 4 problems along with the solutions online as well, maybe just in this video, at the bottom of this video. So part 2b is h of x. Same instructions. We're looking for the power series representation of this function, and then its interval and radius of convergence. In other words, where does this function equal that power series? When I go back up, g of x cannot always be written like that. It can only be written as this power series on this interval from -2/3 to 2/3. Otherwise, the power series itself here diverges and never equals this fraction g of x, this function g of x. Okay, scrolling back down. So our goal again is to get 1 over 1 minus something here for h of x. So to do that, we just take those constants on top and bottom, the 5 and the 3 in front here, and we factor them out. So I'm going to go 5/3 times, and now it's going to be 1 over, well, it's going to be 1 plus x. But I don't really want a plus here. I need a minus. So I can think of this instead as 1 minus negative x. Oops, and it's not negative x, it's negative x over 3. Sorry, I messed that up. Let me slow that down just a little bit. I pull out the 3, I get 1. I'll do it in 2 steps since I made a mistake. Plus x over 3. And then I need that to be a minus, so I leave my 5/3 out in front. 1 over 1 minus negative x over 3. And that's my 1 over 1 minus a. And then I can get the power series representation of this part because it has the right form. So I leave the 5/3 out in front. I get the sum. I'll just leave it blue. But I was going to make it yellow so you could see the two things, but we don't need to. It's hard to see the yellow. The sum from n equals 0 to infinity of whatever's in those parentheses, negative x over 3 to the n. And usually, we would rewrite this. We might leave the 5 out in front because it's not related to this third there. But then this would be the sum from n equals 0 to infinity. We would write negative 1 to the n, alternating, and then 1/3. We have to the n times the third there, so now it's to the n plus 1. And then again, times x to the n. I'm okay with either of these. Again, I just kind of want us to recognize, when you do this alternating, usually you pull that negative 1 out. It shows up separately. And then we're done, but these two things are not always equal. They're only equal on the radius of convergence, or the equal on the interval of convergence. So again, we take this a here, it's negative x over 3. My pen is messing up. Put it in absolute values, that has to be less than 1. So these two things are equal. When this is true, ignore the negative. That means that x over 3 is between negative 1 and 1. I'm not ignoring it, I'm just taking the absolute value, which becomes, I can write it like this. Multiply all this by 3, you get x is between negative 3 and 3. Again, this is centered at 0, so we have the interval from negative 3 to 3. That total distance is 6, divided by 2, or just recognize the radius of convergence is r. Okay, so I wanted to give you a couple more problems so that you could do that first worksheet, Power Series 1, or you could even just do these problems again. I'll post this worksheet, and then if you wanted to work on that Power Series 1 homework, you could. All right, great. Have a good weekend.